And what I really wanted to do this evening was to talk a little bit about the geology that underlies York in both its sort of physical sense and also in a more sort of academic scientific sense, what geological advances that have been made in this city. And I guess we get quite a lot of presentations on the history of York in various ways because there's so much of it. But I've never really seen much in the way of a deeper time discussion of going really back into the geology and geography of the city. And as a geologist, that's kind of what I mentioned in the people, but the rocks and the landscape and why it is the way it is and why it is here is something that's been interesting me. I'm also using this as an opportunity to plug a couple of activities I'm doing in lifelong learning and also an event in the Festival of Ideas this summer, which I'll come back to. And I think one of the points I love making to students of all kinds, whatever lectures they may be, whether it's university undergraduate lectures or public presentations, is that in some sense geology underpins everything. If you can't grow materials, you have to mine them. And of course what you grow is dictated on by what the landscape is, so the geology underlies what grows. So if you're talking about everything around us, if it's either been grown or mined, it is dependent on the rocks. And of course people have interacted with geology in a variety of ways for an incredibly long time. And I only recently started chatting with colleagues in university archaeology department. My other half is an archaeologist here at York in the university, and we were chatting about the Stone Age in some sort of broad sense. And I was thinking, it's funny about who were the first geologists. You know, how did people figure out what stones were most useful for different activities? And I guess if you've got a lot of time, you've got a lot of time for trial and error. So I'm sure people must have tested out all sorts of different materials to see what worked. But this is just an image of one of the York hoards. You can sort of search online for the York hoard and find you get taken to different places depending on which period of time that particular hoard is from. But this is a Neolithic, so a new Stone Age, a later Stone Age hall of worked flint. And the interesting question here is that there isn't any flint naturally occurring in the area around York itself. Where does that come from? You can actually find it loose in some of the sediments that fill the Vale of York. But in terms of its origin, there are no flint-bearing rocks particularly close to here. And so what I kind of wanted to do was really to talk a bit about why we think York is here, what the landscape of this region is like, what lies beneath it, both in terms of the landscape physically as we see it today, but also at greater depth, and then sort of delve into how people have looked into this topic, how we've tried to understand what the landscape tells us. And some of you may know this, some of you may only sort of think about it perhaps in a more distant way, but we are right here standing on, or sitting down on I suppose for most of you, a piece of relatively high ground in a broadly very flat landscape. So the Vale of York is a very prominent flat lying feature between an otherwise quite high region of geology. We have the Pennines over to the west, we have the moors and the wolds to the east, and so much of our northern English landscape is relatively hilly, and the Vale of York is a very important lowland region. And one of the arguments for why York is such a historically important location is because, in terms of just a natural passageway through from the south of England to the north, the Vale of York is the easiest sort of route to take. But that still doesn't explain why York itself is where it is. And for that we need to have a look at this. This is effectively a topographic map of the Vale of York with just really the landscape shown, so stripped away all the sort of human settlement. And you'll see York in the sort of middle of the image. And the green is, the paler the green, the flatter the land, the darker green, the slightly more elevated it is. And you'll see that York sits, well, obviously we know it sits on the confluence of two rivers, the Foss and the Ouse. But what they're actually doing is cutting through a ridge of higher ground that runs right across the vale. And indeed there are two of them. If you go a few miles further south, you will hit another ridge. That ridge to the south is the last moderately high piece of ground in the Vale of York, and that's around Escrick. And you'll see two arrows pointing to the York moraine and the Escrick moraine. Now, a moraine is a term for a glacial landform, so a structure that has been produced by ice. And I can show you what the Vale of York might have looked like around about 14 to 12, 11,000 years ago. Because what you'll see there is a glacier, a valley glacier moving down a gap in otherwise more upland region. So frozen water moving down the lowest point in the landscape. And what it does, what the ice does as it moves along, is it transports enormous volumes of broken up sediment and rock with it. And when it stops, that rock will get dumped in various places, but particularly along the snout of the glacier and along the edges of the glacier. And those deposits left along the edges along the snout are known as moraines. And in the case of the York moraine and the Escrick moraine, they're what's called terminal moraines. They're at the terminus, the end of the glacier. And we can look at modern ice age, we can look at modern glaciers, we can look at ice age deposits in various other parts of the world and sort of piece together an ice age history. And what researchers have argued is that the Escrick moraine marks the furthest south that the ice got in the Vale of York in the last major ice age. Now, there were ice ages before that went further south, but in terms of the last main ice age, around, say, 14,000 years ago, the glacier in the Vale of York got as far as Escrick and dumped this ridge of sediment, and then it retreated somewhat, a few miles, and stopped again, and dumped another load of sediment, and that became the York moraine. Now, you could say, well, why Escrick moraine or York moraine? Why is it that we're here in York, not in Escrick 8 miles further south? Well, that point where conveniently the two rivers meet and cut through the York moraine naturally gave an excellent location for navigation. It's also thought that there's, until more recent modifications of the river systems, that there was something of a tidal influence all the way up the river Ouse to York. It's not really present in any meaningful sense now, but there are occasional glimpses of this from records, so not least things like the way that animals move up the river from the Humber up the Ouse. And there is even a tidal bore. One of the participants in one of my evening classes a couple of years ago said, I think we don't know about the Severn having a bore, so the tidal wave effectively gets funneled up the valley of the Severn. The same thing happens in the Humber, and it's more noticeable on the River Trent than it is on the Ouse, but you can, if you get the strong enough tide, follow a tidal wave in the true sense, not in the tsunami sense, up the river, and that has brought various things with it. It is said in about 1908, I think it was, that a narwhal, so on the white whales, made its way up the Ouse as far as Neyburn Lock, and then got sort of stuck, couldn't go any further. But the idea of seeing a white whale coming up the river is quite something. So it's water in both its liquid and solid form that we have to thank for the location of York as it is, as a navigable but still elevated spot in the landscape. And we can actually find, annoyingly, I couldn't find a good photograph of all the stones in museum gardens here in York. But actually, when you leave this lecture theatre, if you walk that way, have a look in the gap in between this building and the next, or if you walk the opposite way and go up towards the science park, and you go up the path there, you'll find these rather odd, very large boulders sitting kind of incongruously in the middle of the university. And those are so large, they can only be transported by one of two mechanisms, us or glaciers. There's no other mechanism of transporting material that's strong enough to pick up really big bits of rock. Now, obviously, we move things around quite a lot, so there are what we call erratics, which are human erratics, things that aren't in the place that they should be, that we've moved around. And in fact, most beaches now have a mixture of glacial erratics, so pebbles, rocks that have been moved by the ice. And in fact, if you go somewhere like Filey and start picking up the pebbles, you find an extraordinary array of different pebble types. You can find ones from Norway that came over in the last ice age when the North Sea didn't have any water in it and the ice sheets were moving across from Scandinavia. But we move things now. We move rocks from Norway. The Whitby Harbour protection is mostly Norwegian rock. But in museum gardens, there are a number of stones that have been left there, and there are various sources. One is said to be from when they were preparing the railway and they dug up a large lump of Cumbrian granite, and that's in museum gardens. Osbaldwick claims some of them were from the village there and then left in museum gardens later and transported. The top right image is one of these large boulders, and that's speculatively thought to be from the Lake District. The path that the ice moved would be from the lakes. Lake District are the real high point where an English glacier system would have developed in the last ice age, and then the ice would have radiated out from that Highland region, and the Vale of York is one of the routes that the ice would have moved down. So pieces of rock from the Lake District got transported all the way down the Vale of York. You can even find fossils as erratics. A friend of mine emailed me this week to say he found what's colloquially known as a devil's toenail, a Jurassic oyster, in Potterick Carr Nature Reserve, in the Yorkshire Wildlife Trust Nature Reserve. Now, there are no Jurassic rocks that should source a Jurassic oyster, but they're actually quite tough little fossils, and they're mostly found in the northern part of the North York Moors and Redcar, that kind of area. So it's more than likely that they've also been picked up and transported, because you also find them at Filey as pebbles, effectively, that have been transported down the coast. The bottom left image is really just an example of this. This is near the station at Seymour on the way to Scarborough, and that's a huge lump of granite. There are no granites anywhere near Scarborough naturally, and that has to be a glacial erratic. But if you go to museum gardens, you will find a number of large boulders that are not, they're actually sort of erratic erratics. They've been moved by the ice and then by us. But some of them even have telltale scrape marks over them. You can actually see what are known as striations, grooves that have been, where the rock has been sort of smoothed over by the action of the ice moving it along. So you can get a sense, even though now we're not in an ice age world, that there was once a mechanism for moving very large amounts of rock and sediment. So this is an image from a paper published a few years ago, just trying to summarise what the broad sort of ice age geology of the region is. And that dashed blue line is the maximum extent of the ice in the last ice age. So based on what the different deposits tell us around North Yorkshire and then west into the Pennines and south down Doncaster, we can map out where the ice got to. And interestingly, it seems that the North York Moors were not covered by ice. There was ice in the North Sea, well, there wasn't a sea at that point, banking up against the coast. And then there's ice coming down the Vale of York. But the moors themselves were mostly either ice-free or filled with water. And the Vale of Pickering is a glacial lake, effectively. The sort of the muddy sediment that fills the Vale of Pickering, that's good farming land, is lake sediments that pile up on top of that. And if you're aware of the site Star Carr, which is such a famous archaeological site in this region, that sort of people living around the edges of this diminishing lake that finally disappeared a few thousand years ago. You don't need to worry too much about the detail. It's really just trying to show that there are lake deposits, there are river deposits, there are tills, which is a glacier material. So that the blue that you see above and then to the east of the ice limit line is glacial till. So what tends to be known in the old days as boulder clay, because you tend to find it was either really fine clay or big boulders. Depending on how soft the material was and how easily broken up it was, you tend to get the really hard rocks remaining as lumps, and then the finer material being broken down into small particles. It now tends to be referred to as till because there's different types of till that people can identify, and boulder clay is a bit too generic. And yeah, you can hopefully see that the blue line that is just to the southeast of York kind of marks where the Esprick moraine is, and then when the ice retreated a little bit, it left the York moraine, which we are on here in Heslington. And indeed, there's a publication that university produced as part of the Heslington Dig that explains a bit more about that if you want to find out on the university website. Now, I'm a geologist, so I'm tending more interested in rocks than sediments. Or I'm interested in sediments, I'm particularly interested in marine sediments, so what's going on in the sea. So I'm not really an ice age expert by any means. And what I'm always interested in is what lies beneath that. Now, in the Vale of York, we don't see any bedrock. There's such a thick covering of ice age sediment and then river sediment on top of that, that there's almost nowhere within the Vale that you actually see bedrock. You have to drill boreholes down into the bedrock to do that, or you map out what's going on elsewhere in the region and start predicting where the beds are going. Now, in general, across the Vale, so this is a geological map of what, if you stripped away all the superficial deposits, you'll tend to get this sort of geological snobbery of sorts, that the hard rock geologists are the superficial, the drift, the stuff that just, the gardening, in essence. Just strip that all away, you want to know what the bedrock's like. That's what it would look like if you got rid of everything. And you'll see that the Vale is a prominent geological feature, that there's two sort of pinkish buff kind of coloured units that dominate the width and length of the Vale, and those are both Triassic sedimentary rocks. So there's a mixture of sandstone and mudstone, and that is relatively soft, relatively easy to wear away, whereas the limestone and sandstones of the moors and the limestone and sandstones of the Pennines of different ages are a bit more resistant, and so you kind of have a natural capacity to erode, and so those softer rocks have been weathered away down the Vale. If we were to drill down beneath us a few metres, it varies a bit. The thickness of the cover varies from place to place, but a few metres is typically the case. It does vary across the Vale. You would hit, from York, from here, red sandstone. And that, to say, is Triassic. So the Triassic is the period of geological time immediately before the Jurassic. So if I tend to talk to people about geological time, Jurassic is one period that people are reasonably familiar with. The Triassic is the period before that. And the Tri part of Triassic refers to where in Germany it was first described. There were actually three common rock types: red sandstone, white sort of chalky limestone, and darker muds. Now, we don't have much in the way of the limestone in Britain. We only really have the red sandstones and the muds. So in the UK it's really Biassic rather than Triassic, but the name was given based on what the rocks were like in Germany. And if you want to actually go and see what the rocks really look like, you have to go down to places like Nottinghamshire, where it's this rock, this red sandstone that underlies York is known as the Sherwood sandstone. And in fact, if you want to go and sit in a geological pub in Nottingham, the old Trip to Jerusalem Inn, which is reputably the oldest pub in England, but people argue about exactly which really is, but it's carved into the Sherwood sandstone, so you can actually sit in rooms where you are sitting inside a desert dune system. And I went to a geological conference in Nottingham at Christmas, and we got to do this, and it's a strange pleasure to be able to sit inside what you know. When you look at the grains of sand that form the beds within the Sherwood sandstone, they're all rounded, very, very rounded, very similar grain size, and they're almost all covered in little reddish iron oxide, so rust, effectively. And that is classic desert sand. If you go and collect material from the Sahara Desert, it looks like that. It's just not yet been lithified. And so we think that the Triassic was a period when Britain was covered in desert sandstones with a lot of wind blowing dunes of sand around, occasional water around, because you can't form iron oxide rust crusts without having some water present. And so these sandstones are better exposed further south. And in fact, you can pretty much follow them right down to the Devon coast. There's a band of these red sandstones that runs all the way down to the World Heritage Site. So if you start on the Devon-Dorset Coast Walk, you'll be in effectively the same rock type. The unit that then, if you were drilled down further, you would find beneath those red desert sandstones is the slightly yellowy limestone. It's not strictly limestone, I'll sort of come on to that, that you see if you drive down, again further south, but down the A1 ridge. So those road cuts that you see as you drive along the A1, and here's an image of those on the right hand side, all these layers of slightly yellowy looking sedimentary rock. That is what's generally known as the magnesium limestone. If it was normal limestone, that's calcium carbonate. In this case, it's magnesium carbonate. And that's the sort of limestone that starts to form in a very arid desert sea type setting. So whereas the Triassic sandstones are a dry desert system, probably say something like the Sahara at the present day, the rocks that underlie them are a little bit older, the Permian, the last period of the Paleozoic era. These are of broadly sort of Saudi Arabian sort of Sabkha sandflat type environments. If you ever went out to Saudi Arabia, you see these huge expanses of very salty, flat, sort of marginal marine environments. Those are broadly equivalent to the sorts of things that we have at depth. And that magnesium is really good because it means the water that passes through it is very good for brewing, which is why Tadcaster has remained a brewing centre. Tadcaster sits on the magnesium limestone, and the water's perfect for brewing, so they've never needed to move. And in fact, again, you'll tend to find most of the breweries around the UK are centred on water, on locations where the water is a bit hard and magnesium rich. Now, as far as I'm aware, no one's ever drilled any further down the Vale of York, but we can predict, based on a general stratigraphy, that the rocks that underlie the Permian would be the Carboniferous rocks, the coal measures. But I'm not aware that anyone's ever actually drilled to prove that. Of course, in a place like Selby, the coal mines are demonstration that there's coal beneath it. So beneath York itself, we don't know for sure, but we can make a fairly sensible assumption that based on the coal fields to the south and east, that there are coals beneath us, which is why there is some interest in this area for drilling down to see if there's any gas in the coal. And I discovered recently that I live in a license block for coal bed methane extraction, which could be exciting. Now, to come back to York itself, the interesting thing, of course, is that it's a great location within the Vale by virtue of being a ridge of sediment that's a higher spot with an otherwise flat landscape, and obviously the rivers are very useful. But as Gaunton Buckland pointed out in 2002, for all the sort of Roman sites that became significant centres of long-term population, York is slightly odd because compared with the Roman sites, it has one major disadvantage, that there is no suitable source of building stone for at least 15 kilometres in every direction. So that is an interesting challenge. Clearly York was deemed to be important enough as a location that issue could be overcome. But it's not a small issue because moving rock to build things is a very expensive business. And so the idea that there's nowhere particularly nearby does raise that challenge. But clearly, for various reasons, it was deemed to be worth persevering with. And this map that's in the paper by Gaunton and Buckland just tries to give a general sense of, so all the white part of the map is where there's no bedrock, it's just ice age sediments, and then the different ornaments of different parts of the map indicate the different hard rock that was available, and you could go east into the Wolds and find limestones and some harder chalks you could utilise. You go north-east into the North York Moors, and there are sandstones and limestones, and then west into the Pennines, where obviously there's a lot of harder rock. And we can actually see that to some degree when we look at the city itself. York doesn't have a great diversity of building stones. And I was chatting with a couple of friends who work in the York Museum, in the Yorkshire Museum. They were saying it's a little bit tricky if you're giving a guided tour. Some cities are great for guided tours of building stones because they have lots of variety. York actually doesn't have a huge amount of variety. When you get your eye in, you start to see there are There are places with a bit more of a mixture, but as you'll have no doubt seen, most of the obvious old buildings are built of one rock type, this sort of yellowish limestone that is the same stuff that occurs on the A1 road cut down towards Doncaster, this Permian dolomite. So dolomite is magnesian limestone. That's the dolomite is the sort of the technical term. Dollar stones are also used as an alternative. And this was quarried mostly sort of in the Tadcaster sort of area, and then brought up to York. And so the walls and the minster and many of the earlier buildings are constructed of this yellowish carbonate rock. And I do wonder that's perhaps why I'm not sure whether that's why the daffodils grow well on the walls, but there's certainly a nice and yellow contrast. But what's noticeable, there is actually a change. When you look at the age of the buildings around York, those that are sort of medieval and older, or sort of the early parts of the last millennium, they are mostly magnesian limestone. But more recent buildings, 19th century and 20th century, particularly with the railways, the routes had begun to change, and so you start to open up the possibility of using other stones. Interestingly, the Minster itself, a lot of the problem stones in the Minster, I was chatting to one of the stonemasons, was saying that the problem stones are not necessarily in most cases the old stones, because the magnesian limestone's fairly stable. The problem stones have been things that were brought in the 19th century, which turn out to not be as robust. So there's a particular use of Ketton stone, which is from Rutland, and that presumably came up primarily on the sort of East Coast rail line. But that stone is much more vulnerable to weathering, and so they're having more problems with the Ketton stone in the sort of more recent bits of the building than they are with the magnesian limestone. Mainly that's because the calcium carbonate of a normal limestone dissolves over time in slightly acidic water, so rainwater and water that's running off over a building will tend to have a slight acidity to it, and over time the lime will dissolve. But magnesian limestone dolomite is much less susceptible to that dissolution, so it's more robust as a rock type. So one of the other stones you do see used, and this is so more noticeable in some of the bigger sort of 19th century churches, but also here some of the much older materials. So the Romans didn't just use. So here we have the Multangular Tower in Museum Gardens. You can see some of the sort of pale yellowish blocks in the tower itself that are magnesian limestone. But these coffins that are at the bottom of the tower are of carboniferous sandstones, what's colloquially known as the millstone grit, and the hard millstone material that was used in the Pennines was imported into York again for use in various building stones. And some of the 19th century churches, you can see there's a rather different type of rock there. It's a different colour, it has different textures. In fact, if you get it under a thin section, which is what the British Geological Survey have kindly provided us with in this top right image, so that's a magnification on about 100 times. It's basically made up of grains of sand that are cemented up, that were deposited in an ancient river delta sort of system. A lot of the paving slabs as well are carboniferous, and York stone is quite a famous flagstone, paving stone. It has nothing to do with York. There are no stones actually in York. It's just, I think, because York claimed the ownership of a lot of things for the region, that it was brought from other parts of Yorkshire and then just became known as York stone. You'll find it York flags, York flagstones, various terms for it. They tend to be thinner sheets of sandstones that split as sort of more like paving slab approaches, so they can also be used as bedding. The museum in Museum Gardens is interesting because it was built in the late 1820 or 1830. It opened. At that point, the magnesian limestone doesn't seem to have been so readily available. Or we'll come on to the people who built it. But this is actually made of Jurassic sandstone, a slightly limey Jurassic sandstone from near Scarborough. The Hackness stone, and Hackness Hall had its own quarries just slightly a few miles outside Scarborough. and they were brought over to be used in the building stone. And you'll notice a very significant difference. If you go around, I'm a paleontologist, I'm always looking for fossils. When you walk around the walls, it's a very frustrating business because there are virtually no fossils to be found. You think limestone's a good rock normally for finding fossils in. Magnesian limestone is not, particularly probably because these hostile, salty seas were not the sorts of places that lots of things like to live. So even if there were animals around, they're not that easily fossilised, but there probably weren't that many things living in these Permian environments. In the Jurassic, conditions in Yorkshire were a little bit more amenable to life, and if you go and have a look at the museum building stones, you'll often find there are little tubes running through them and other sort of structures. You can actually find fossil burrows and occasionally fossil shells inside those blocks. So if you're waiting for the museum to open at any point, have a look at the building stones and you'll actually start seeing there are structures in there that give signs of life moving through the sand. And of course, more recently, with the mobility of building stones, and indeed the shutting down of most of the sort of major British sources, and then the importing of cheaper material from elsewhere, you'll find a lot of exotic, so they're sort of erratics of a new kind, typically Chinese or Scandinavian, or elsewhere in Europe, igneous and metamorphic rocks, crystalline rocks that polish nicely. And so tend to find banks and other sort of higher status institutions used more exotic stones. And the Thomas Cook Royal Bank of Scotland building on Nessgate has some beautiful crystalline structures in those spaces. You can actually go and see the mineral labradorite or labradorite, depending on your preference, which is, as the name suggests, mostly found in Labrador in Canada, but actually occurs right across Scandinavia and other parts of the world. And there's lovely iridescent crystals that you can see in those surfaces there from a very long way away. Weirdly though, you can find pebbles of them sometimes on the beaches of the North Yorkshire coast, because the same material has been shifted across by the ice, but never as blocks you could really use for building stones. Having talked about the rocks, I want to at least talk a bit about the people and the geologists of York. I'd say it's an interesting situation because for me, as a geologist, when I moved to York, I was hoping I could find work here, and I've managed to sort of manufacture work for myself by doing the lifelong learning and teaching. But the university doesn't have a geology department. There are some geologists in other capacities in other departments. And so you tend to sort of think that York is not a city in which geological research really takes place in a big way. But when you delve back into the history, it turns out to be one of the most important geological cities anywhere, really. So I'm going to sort of give a whistle-stop tour. The Yorkshire Philosophical Society website provides some excellent biographies of a lot of people, so if you want to delve into more information, I would recommend going there. And one of the guys that is included on their website is this gentleman who was a doctor, Dr Martin Lister, was not from York and didn't die in York, but lived in York for 13 years in the late 17th century, and not particularly well known, and actually not particularly well known in geological circles, I'm ashamed to say, despite the fact that he could arguably be put down as the first sort of British paleontologist and the first person to really think about geological mapping. This year is the bicentenary of William Smith's geological map, which is often described as the map that changed the world. In 1683, Lister wrote a treatise, which I'm not going to read out but in detail, but it says, an ingenious proposal for a new form of maps of countries together with tables of sands and clays, such chiefly as are found in the north parts of England, drawn about 10 years since. And he basically describes the soils, the rock types that occur around northern England, and recognises that they have a systematic pattern. But nobody was quite prepared to follow him up on it until William Smith, 130 or so years later, who realised you could go and map the units. But what Smith realised was the fossils were key to it, which is interesting again because what Lister was very interested in was fossil shells, and he found ammonites, now we know extinct fossil mollusks, and he had trouble explaining them because he could tell that they weren't like anything else he saw around him. He compared them with nautilus, the living sort of shelled mollusks that found in the Pacific, in the Indian Ocean. They could see, even though they were similar, they weren't the same. So he argued that either they were a form of land mollusks that we didn't know about, or they were an extinct group of mollusks. And that was quite a revolutionary idea in the 17th century. The idea of things becoming extinct rather challenged the idea of a sort of a biblical creation and all things still being alive that had been created. So he was really quite a radical thinker, and perhaps the world wasn't quite ready for some of those thoughts. Now, he was part of a group that I think were called the York Virtuosi, and there were various people having scientific meetings. But it wasn't until the 1820s that York actually really kind of got going in a more sort of organised scientific society way. And what's interesting is that classic thing of what your neighbours do push you in a particular direction. Leeds, Sheffield and Hull had all established scientific societies, philosophical societies, and there was I think there was an editorial in the local paper that said, do not these useful institutions convey a severe reproof to the tardiness of our own city? Whilst York can boast her associations for fashionable amusements, she presents none of the characteristics of an enlightened and scientific people. What that person didn't realise was that virtually at the same time, the Yorkshire Philosophical Society had come into being. It just hadn't yet been publicised. So in 1822, that began to change. And one of the main reasons for it was, probably the primary reason for it, was the discovery near Kirby Moorside of some extraordinary bones, many of which, as a consequence of development of the Philosophical Society, are in the Yorkshire Museum. And Kirkdale Cave, you can still go there now. It was being quarried for limestone, and the workmen found some strange bones, and eventually these reached the attention of William Buckland, who was a professor at Oxford, and he interrogated these remains. And he's a very interesting man because he became the Dean of Westminster, so he's a very important clergyman, but he wasn't afraid to challenge orthodoxy. And he actually changed his mind a number of times through his life. He believed very literally in the flood geology, and then he looked at the bones in the Kirkdale Caves and kind of went, it doesn't quite work. And people had said, oh, the bones had all been washed in by the flood. And he said, well, the gap in the top of the cave isn't big enough for them to have washed in, and how would they have been transported? And this drawing from around the 1820s of Buckland himself is relating to the fact that he realised by actually getting his own pet hyena, that's the right kind of science. If you have a hypothesis, you want to test it, get yourself the creatures that you need to do. He thought that the bones showed signs of having been gnawed on in a systematic way. And what he realised when he gave modern bones to modern hyenas, and they showed exactly the same kind of patterns, was that the bones were all of a hyena den where the animals had been dragged into this cave by the hyenas and then fed upon in the cave. So it was a bit of a revelation because it was challenging the idea that these were simply flood deposits. And he wrote a series of works about this. And to say the bones, including some of the jaw bones of the predators, are in the Yorkshire Museum to this day. And that was a primary reason why the Yorkshire Philosophical Society was established, because various people had got collections of these bones, but they wanted to have somewhere where they'd all be brought together, could be studied and then curated properly. This gentleman, William Vernon Harcourt, was one of the main pioneers of this. I don't think he would describe himself as a geologist, really. He was interested, but he was more of a chemist in his research interests. But the YPS, the Yorkshire Philosophical Society, was established 1822 and then officially launched 1823, with one of its primary aims being to elucidate the geology of Yorkshire, so to understand what had gone on in the past in this part of the world. And it's still a centre of Yorkshire geological research, albeit perhaps not in quite the active way it was when it first began. And William Smith, I just alluded to, saying the 200th anniversary of his map. This is the map, a version of which will be, or one of the versions of which will be going up in the museum in York in a couple of months' time on display. He came to York having fallen on very hard times and was given employment as a lecturer, giving talks in geology in 1824. And I don't know why exactly, but he couldn't fulfil those lecture obligations, which worked out rather well for his nephew, John Phillips, who turned out in many ways, perhaps isn't as famous as William Smith, but in many ways actually a rather more important scientist. Smith was very astute, but Phillips thought about things in a rather different way, probably having spent a lot of time with his uncle, being educated from a very young age about geological identification, fossil collection and so on. And when he came with his uncle, the Philosophical Society decided to employ Phillips to carry on giving the lectures, and then the following year he was made the first keeper of geology. So 1825, Phillips becomes the secretary and the keeper of geology of the Philosophical Society's collections. And he was an extraordinary chap. I mean, again, there's lots of stuff out there for you to read, so I won't go into great detail, but his achievements across the geological sciences were just amazingly diverse. He was just a prolific producer of excellent geological findings, and much of the beginnings of the Yorkshire Museum are really down to him. 1829, this is in the later version of the map, but he produced a volume of the Geology of Yorkshire and actually described the rocks of the region. And the following year, 1830, the Yorkshire Museum opened as a proper display place for all these collections and for the ongoing development of the collections. An interesting thing then is that York became effectively the second centre of English science outside of London, because the Vernon Harcourt and Phillips and various other members of the Philosophical Society and affiliated bodies became very keen to have an organisation that was not London-centric. So the Royal Society was the big London centre, and what they started off here in York in 1831 was a group that's now known as the British Science Association. I think initially they were just known as the Cultivators of Science. That was the first meeting. They didn't actually have a proper name, but at the end of that meeting they became the British Association for the Advancement of Science. So 1831 in York, that first meeting, and there's been a meeting of the British Association every year since. I think it's in Bradford this year, so it's not gone too far away. But yes, this was just the announcement in an Edinburgh newspaper of a great scientific meeting to be held in York, and all the big sort of non-London and some of the London-based geologists and scientists came to York for a week of talks. Back to Phillips briefly, one of probably his most important sort of recognition developing on his uncle's work was that you could look at fossils through time and recognise that the rocks could be partitioned up by the different diversity and abundance of different fossil groups. And he actually, in 1840-41, just around the time he was about to sort of leave York and start his trajectory up to become a professor at Oxford, he defined the Paleozoic, Mesozoic and Cainozoic eras. So if you're aware of those three terms, York can lay claim to the original definition. The term Paleozoic had been used before, but what Phillips did was to show exactly how the rocks were divided up: old life, middle life and new life. In certain circles, the age of fish, the age of reptiles, the age of mammals, but there's also an awful lot more to it than that, but that's the kind of often the simple way of doing it. I think I'll simplify it for people who think paleontologists only deal with dinosaurs to have the pre-dinosaur period, the dinosaur period and the post-dinosaur period, just to simplify it down to the very, very tabloid level. Phillips and Buckle and all these other guys had begun to realise the depth of geological time could not be as the Bible claimed, but they didn't really want to stick their neck out and say how old it was. It fell to a Yorkshireman who was then working in Cambridge, Adam Sedgwick. The next time the British Association came back to York in 1844, the Dean of York Minster, William Coburn, was very much a scriptural geologist. The Earth was 6,000 years old. Archbishop Usher had calculated this in the 17th century, and that was the truth. And the geologists who said, it isn't, it can't be, I can show you why, were heretics. And so Sedgwick, unfortunately, was the kind of scapegoat for that meeting and was shunned from the dinner. He wasn't allowed to go to the Minster. He was basically, Coburn and his allies said, no, this chap is a heretic, even though Sedgwick himself was also a minister, but he was deemed to be too liberal and too crazy. With time, of course, we know that Sedgwick was correct and that the Earth is not 6,000 years old. It cannot be. But it took a very long time for the discussions to kind of pan out. And there's a lot of literature out there, again, if you want to read into more detail of these battles in the 19th century. I would like to at least mention John Phillips' sister, who's very little known, but turns out to have been what we've termed, colleagues of mine have a website called Trailblazers, about female scientists who've made significant discoveries and not perhaps been recognised for it. And Anne Phillips should be recognised as that, and I helped write a piece last year about her life. because she worked with John very carefully, very closely. Unfortunately, we only have one half of the letters. We have in John Phillips' archive in Oxford the letters on one side, but not. We don't have her letters. We have his letters that have been retained, but not hers. So we don't quite know the exact dynamic of what they were doing, but we do know that she went on a number of geological field trips with him and was actually very key in identifying things that other geologists had identified wrongly, including in the Malverns, figuring out how the Malverns had formed, and disagreeing with some of the very high-profile geologists of the time. So it's something we'd love to know more about, and it's something that hopefully there are archives out there that can help us find out exactly what she did, but we know from the limited information that she was also somewhat geologically indoctrinated, probably by her uncle as well. And if you want to go and see them, they are buried in York. So although John Phillips became a professor in Oxford, after he died, he was escorted by a great cortege of Oxford dons to the station, and the train brought his coffin back to York. The Minster bells tolled for, I think, 90 minutes as he was led to as the cortege went to the cemetery, York Cemetery, and he is now buried there in a very simple grave, but from a man who contributed so much geologically. His sister is also buried there. It's a rather overlooked little spot, so if you do go into the cemetery, it's worth seeking out. And I guess the last sort of notable geologist I'm going to at least touch upon, and again, the YPS website has a lot of information about Tempest Anderson, but as a man going into the 20th century, so most of the guys talk about the 19th century, going into the 20th century, and the fact that he was an ophthalmologist and photographer was extremely useful. Now his archives have been made publicly available through the Wikimedia project. So the Yorkshire Museum photograph set of his photographs of volcanoes erupting. And this is Mount Pelée in oh, my mind's gone blank, it's Martinique or Montserrat, I can't remember which of the West Indian islands, but anyhow. That's one of the big eruptions in the early 20th century he actually photographed, and his records are extraordinary documents of early science into the sort of how volcanoes operated. What I do find interesting, and I'd be interested if anyone has any information that sort of follows on from this really, is that after Tempest Anderson, the geological side of York as a city seems to kind of begin to fade away. We had all these really high-profile figures in the 19th century and into the early 20th century. Sort of begins to die back somewhat. And I've been sort of racking my brain trying to think of who in York would have been a sort of similar figure to these guys, and geologically I don't think there really are any. So I've been left with my own tributes to a small number of colleagues who have worked in the Yorkshire Museum. If you want to know anything really about the geology of York, the building stones, the museum, then Stuart in the middle, Stuart Ogilvie, is definitely the man to speak to. His knowledge of York, of its geology and natural history is just exceptional. So if you have any questions on those topics, do go and pick his brain. Phil Manning's now a professor at Manchester, but was keeper, in fact, the last keeper of geology, I think, at the Yorkshire Museum. And Paul Ensom was also a keeper who then wrote the book Yorkshire Geology, which you can consult. Obviously, slight concerns of funding longer term will also happen. The Yorkshire Museum is inevitably being stretched for cash, so they've just been announced they're facing a £500,000 cut, so what that will do to the future of geology, I don't know. It doesn't bode especially well. One of my friends is the curator, and they haven't replaced the assistant curator that they had before. But I'm going to sort of try and end up on a somewhat positive note and say, well, we are through lifelong learning at least trying to keep some of the geological activities and traditions going, and this is, as I said, this new online diploma in geology, the geology of Yorkshire and Northern England, that will be run starting in the autumn through lifelong learning, but online, distance learning, and you can go to the website and find out more if you're interested in that. I crowbarred this slide in about half an hour before the talk started because I realised that I've not included it. I'm actually doing a day class on the geological history of Britain through lifelong learning next month, so if you're interested in that, Saturday, March 15th is going to be the day I'm going to try and rattle through the geological history of Britain in one class. And as part of the Festival of Ideas, myself and a couple of geological colleagues are going to do a not entirely truthful guided tour of the natural history of York. It will be mostly truth, but there will be some lies in there, and your task as a participant is to work out which of the crazy sounding stories is true, because most of them are, and which are not. So we will begin in the museum and do a tour of York and come back to the museum with various characters appearing through that 1 hour, give or take, presentation. So there'll be more coming up when the brochures and websites and so on go live. But the natural history, the history part is deliberately spelt with a certain hysterical twist. And last but not least, if you fancy a day trip to Scarborough in September, we have the second Yorkshire Fossil Festival happening there at the Rotunda Museum, which is the sister museum in terms of building stone. William Smith and John Phillips were involved in the building of the Rotunda Museum, which is built of the same Hackness stone as the Yorkshire Museum. And we shall be there from the weekend of the 18th to 20th of September. Thank you very much.